Welcome to Module 4 on Detailed Project Example 1, ABC Decision Process with Positive ABC Decision. We're pleased to again welcome our speaker, Mike Culmo, Chief Bridge Engineer with CHA Consulting, Inc. Mike?
Thank you, Mary Lou. The next two modules will consist of detailed project examples. Mary Lou has long told me many times that people who attend ABC webinars love to see actual project examples of actual ABC projects. So for the next two modules, we'll go through two ABC projects. The first will stay positive. ABC was a positive decision. The second is where ABC was a negative, that we didn't use ABC. However, you'll see in the second project, we actually did use some prefabrication techniques and some ABC techniques anyway. But let's move into the first example. So this first project, the first two we spoke about earlier today were the first ABC projects were in Western Connecticut. The two we're going to talk about this afternoon are in Eastern Connecticut. Now, granted, Connecticut's a very small state. To go from one side to the other takes about an hour. So it's for states like Texas, these two projects are almost in the same town. But this is in Eastern Connecticut near the Rhode Island border, located in the town of Waterford. The project involves a crossing of Interstate 395, which is a 4-lane divided highway, over State Route 85, which is a 2-lane rural highway. However, Route 85 is a significant connector road. If you look at the map, you'll see Hartford is located in the center of Connecticut. New London, which is a major city in Connecticut, there's a line that connects the two. The majority of this is divided limited access highway, but the last little bit here is Route 85. So quite a bit of traffic is off the end of this highway and take this local road. So ADT is quite high on this road. So it is a significant roadway both above and below the bridge, which is why ABC was really considered initially for this project. Zooming in a little closer, the project location here, you see Route 395 is running essentially diagonally from southwest to northeast, and Route 85 is perpendicular to that, running from northwest to southeast. It's also known as Hartford New London Turnpike, which if you could, that is the connector road between Hartford and New London. At some point in the future, they're going to finish that highway. We've been talking about it for 30 years and it hasn't come to fruition yet. But right now, Route 85 is a fairly major road. Zoom in even a little closer, and we look at the project sites located right here, and you see very close to our site we have a racetrack, a stock car track is very close. We also have some very significant retail. These are shopping malls in this area, which is why we have such high ADT. Not necessarily the racetrack, that's really a weekend thing, but during the week we get a lot of traffic, shopping traffic, and just commuters running through this area. And you can see another feature of the site is 395 breaks off of Route 95 at this point. 395 runs all the way north to Worcester, Mass, and 95 continues on to Providence, Rhode Island. So there's quite a bit going on in this area, which is why we're looking at ABC here for this site. Zooming in even closer now, we look at the interchange where this bridge is located. It's a typical diamond interchange, which played significantly into the decision process for this project. It's a 2-span bridge. I'll zoom in even closer. We have a 2-span bridge with span 1 over Route 85, which is 4 lanes going through here. To the northwest of here, it's a 2-lane road, but from this point to the southeast, it switches to a 4-lane road as we get closer to those shopping malls. The second span is located over a parking lot. It's a commuter parking lot, so it's something that we had access to during construction, which came in handy. So elevation of the bridge before construction, again, a 2-span rolled beam stringer bridge, very common bridge for Connecticut, built in the 1960s and 70s. Just a plan and elevation view of the bridge showing it has a skew angle of approximately 30 degrees, 2-span bridge, nothing too unusual about the structure. I'm not quite sure why these footings are so low on this side. I'm sure there's a geotechnical reason for it, but this is just the existing plan and elevation of the bridge. Cross section is your typical 1960s vintage interstate highway bridge with rolled beams, composite concrete deck. We do have a raised median, which played into some of the decision process as well, and older barriers and parapets that need to be replaced as well. Framing, very simple framing, again, approximately 30 degrees skew, typical stringer bridge. So what was the need for the project? And the need really boiled down to the deck was in poor condition. 15% had significant deterioration. One span 2 had 18% deterioration, and we're talking significant deterioration, not just a few bad spots. Dampness up to 90% of the bays were damp, meaning there was moisture getting into 90% of the bridge deck after a rain event. So the waterproofing membrane that was put down, we had an issue in the 1970s. We were using maybe not the highest quality membranes, and we had some issues. We've since gone to much more high quality membranes and have better performance. And it's funny, the older membranes going back to the 1960s performed very well. We had a period in the 70s and early 80s where we had some issues with membranes, but we've since corrected those problems. So the project scope, a complete study was done of this bridge, and we looked at options of a deck replacement or a superstructure replacement. For the deck replacement, we looked at both cast in place concrete and precast full depth panels combined with full painting of the structural steel. As far as we also looked at a superstructure replacement with new beams, with modular deck beams, and a modular deck beam is defined as essentially two steel beams with a precast deck on top. It also could be concrete. In this case, it was steel because of the span length. We also looked at full replacement with shortening the bridge to a single span bridge and eliminating the commuter parking lot. That was another option that was studied during the preliminary engineering phase of the project. So in order to look at what we're looking at for conventional construction, we look at stage construction, and we had two options that were investigated. Option one was to rebuild the median first, to get rid of that raised median, and then move traffic and stage traffic around that. So that was 3 stages of construction. That was option one. The second option that was looked at was splitting traffic, doing a partial reconstruction of the median, and then doing a full crossover with 2 lanes on the other side of the bridge. So both of these are studied. They were similar as far as traffic impacts and as far as costs, but there were several different. This is probably a little more expensive because of the full crossover of traffic versus the previous one had a partial crossover of traffic. So this is the project site shown in a roadmap showing potential detours that were studied early in the design. One option was to close 395, one of the full replacement options, close 395 and detour it down this route 32, which is a fairly decent road. I believe it's a 4-lane road, but it's got traffic signals and it's a little slower than your typical limited access highway, and get traffic around that way. For Route 85, the only realistic detour was this Route 161, a 2-lane rural highway that would take you around to, this is Interstate 95 that moves along here, and 395 goes to the north here. So the ADTs were high for both of these. The ADT was almost as high for Route 85 as it was for Route 395, or I-395. ADT on 395 was 23,400, which is really not that bad for a limited access highway. That will play into our decision making later. ADT for Route 85 was very high for a 2-lane road at 19,000, which will also play into our decision process later. It is a tough detour for a 2-lane road to push that many vehicles through a 2-lane detour over a significant distance. So let's look a little more deeper. The ABC option is to close the bridge one direction at a time, maintain 2 lanes in the other direction. The idea is to work on half at a time, and then divert the traffic through the diamond interchange. So we're actually going to take traffic, run it down the ramp and back up the ramp, which is a very handy detour when you have a diamond interchange. The idea would be to do a deck replacement. This is where we had honed in on a deck replacement as the structure type that we're going to use. So it would allow us to run traffic down here and attack one side of the bridge at a time. And the estimate was that we could build that in as little as 1 week based on our experience with the previous projects. One option was to modify traffic signals at the base and keep 85 open. Another option would be to close 85 and detour it. So those were 2 options as far as dealing with traffic downstairs. So the idea was that we might not have to detour traffic on 85 because for the most part, the impacts to Route 85 were not that significant since we were just doing a deck replacement. And the thought was we can use off-peak travel hours to do things like deck removal and erection of panels. So the thought was maybe we can keep 85 open. So the project scope, as I said before, was honed in on as a deck replacement with precast deck panels and full painting. We decided to use the details very similar to what we showed you from 1990s of longitudinal post tensioning for the connection of the decks with grouted joints, and then rehabilitation of the substructure was also in the cards for this structure. So the ultimate decision was to keep 85 open, but let's just say, well, what if we wanted to close 85 to really get this free flow of traffic through this intersection and close 85 down and detour cars around? And so let's see how bad that is and see why we wouldn't want to do that. So again, as I said before, we're going to break up 85 into segments. So in this graphic, this is the detour along this purple orange lines here. And the detour, now I'm trying to be more realistic with this estimate where we're saying cars aren't going from one side of the bridge to the other. The cars coming from Hartford are either trying to go down Route 85 or go up Route 395. So we're actually setting a detour from this point right here down Route 161 and then onto 95 and back up, or onto 95 this way. So we're taking a little more realistic approach, saying that most of these vehicles are not going to go from here all the way around to there. That's not going to happen. So segment 1 is Route 161, 2.5 miles. It's a 2-lane road. Snapshot of the road is shown in the upper right. Speed limit is 45. It's actually a pretty nice road for a detour. And it's got one traffic signal right at the beginning. There's one traffic signal to start. So it's not a bad detour. Again, we're talking 19,000 vehicles per day. This is a busy road. So with this segment, we go into the spreadsheet as we showed before, and we calculate, we put in the detour segment length, in this case 2.5 miles. Our segment speed is 45 miles per hour. Now we have to calculate a congestion factor. So let's go back to this table we talked about before. The condition at the bridge is Route 85 is a non-limited access highway with ADT in excess of 10,000 vehicles. As far as this segment, it's longer than 2 miles, and there's more than 8,000 vehicles per lane. So we end up with a factor of 2.0, meaning it's going to take twice as long to traverse this segment as it would be if it was free flow with low ADT. Next segment is when you get to the southern end of this detour, which now it starts getting a little more congested, a little more houses, more streets and things like that. And it's a 2-mile segment. It's a 2-lane road again. Speed limit now is only 35 miles per hour because we're getting more congested as far as density of houses. There are no traffic signals along this particular segment. This is a photo of what the road looks like. Again, still a decent road for a detour, not looking too bad so far. However, when we look at the congestion, we are still dealing with high ADT, traveling over a significant distance. So we end up with a congestion factor of 2.0, 6.8 minutes to traverse this section of the detour. Now it's getting a little dicey. We get to detour segment 3, which as we approach I-95, as you can imagine, most of you live in states, the closer you get to an interstate, the busier things get. And now we have shopping, we have traffic, we have entrances and exits from shopping centers, we have traffic signals. Speed limit is now down to 25 miles per hour. And we have 2 traffic signals in this area. This is a photo of what the site looks like. So we go through here and again, 0.6, so it's a very short segment, but we're estimating with a congestion factor of 1.5 now, because now our segment has gone down below 2 miles, and we have 2.16 minutes to get through this last little bit, which is only 0.6 miles. The last segment is getting back on the interstate and heading up towards the bridge, where you, in theory, would get off the bridge and traverse down 85. You could also say people might go this way, but for the sake of this example, we'll say people are trying to get back to this shopping center, say on Route 85. So it's I-95 and I-395, 3.3 miles. These are both limited access highways with travel speeds of 55 miles per hour. There is one signal at the off-ramp. 3.3 miles, 65 miles per hour. Congestion factor, again, it's longer than 2 miles. ADT per lane is greater than 8,000. So we're dealing with a congestion factor of 2, 6 minutes to travel that segment. We have, if you kept track of the bullets on the slides, we have 4 stop signs or signals, averaging, we're estimating 1 minute per signal on average. So we get a detour time of 25.78 minutes. And you can see right now why it was not desirable to use this detour. That is an awfully long time to delay 19,000 vehicles a day for 25 minutes. But let's see how it plays out in the spreadsheet. So how does this rate for ABC? So if we're looking at closing Route 85 and using decision matrix and using that delay time, what does that mean for a score in the decision matrix? Let's take a look. So as far as I-395 lane reduction, we have now reduced I-395 from 2 lanes in one direction to 1 lane going down the ramp. So we take 10% of the ADT divided by 2 to get one direction, and we end up with 11,700 vehicles each way with a peak hourly value of 1,200 vehicles per hour. That's that 10%. That volume is less than the 1,400. Therefore, we have no delay on the ramp. That we can actually, the ADT is low enough, we can detour traffic down this ramp and not have a delay. And there's the calculations from the spreadsheet to prove that. I-395, looking at conventional construction with 3 stages, we estimated 750 days of construction. We're assuming a reduced speed in the work zone, so there's going to be some delay. So we're assuming 15-second additional travel time through the work zone due to vehicles slowing down. So we're adding in 0.25 minutes, 750 days. Again, this is multiple stages of construction, which is why it's 750 days. For ABC, we're going to use the ramps to divert traffic. So the I-395 traffic will be going down the ramps for 2 7-day periods, which are the ABC periods. We're assuming a 15-second delay due to reduced speed going through the Diamond Interchange. So for Route 85, for conventional construction with no closures, we don't have to close the road for conventional construction doing a deck replacement. So really, there's no additional delays on 85 to speak of. It really, we're talking most work can be done in off-peak periods when the volumes are low. For ABC, and if you recall also, the roadway below under the bridge had 4 lanes of traffic, so it's very easy to keep 2 lanes open during virtually all periods. For ABC, we're closing the road with a detour, and we have the 2 7-day periods where we're going to send those traffic through that 26-minute delay detour. So you see the numbers right here. Conventional construction for the roadway below the bridge is 0. For ABC, we have 26-minute delay for 14 days. So the result is ABC is worse, which does not surprise us. We are sending so many vehicles through a very long detour. We actually have ABC telling us we have more impacts. The other thing playing into this calculation is the fact that the I-395 traffic was light. So there's virtually no impact on 395, but significant impact through 85, which is the opposite of what typically happens with ABC projects, where the concern is with the interstate, not with the local road. In this case, the local road is controlling the decision process. So basically, this was an unacceptable level of service, having a 59% increase, a significant increase in driver impact, which is why, as I said before, a decision was made to keep Route 85 open, even with the ABC option. We'll take a look at that in a minute. So how does that affect the decision process again? So let's go through the same process, this time though, looking at keeping 85 open. So for I-395, 3 stages of construction again, 750 days. We're assuming a 15-second delay again for cars going through the work zone. For ABC, and this is if we went to stage construction and kept 2 lanes open. Cars are slowing down in the work zone. We're assuming 15-second delay for conventional construction with stage construction. For ABC, we're going to detour traffic down the ramps for 2 7-day periods. However, before we had a 15-second delay because we had free flow through the intersection, but now we have the intersection with a signal with Route 85, so we're assuming a 2-minute average delay to get through that signal at the bottom of the ramp because you'll be fighting with the traffic on Route 85. So we're assuming a 2-minute delay for 14 days. For Route 85, conventional construction, again, no closures, no delays at all for conventional construction. But for ABC, we're going to assume a 2-minute delay because those vehicles, again, are fighting with the traffic that are coming down the Diamond ramp from 395. So we're assuming cars may have to go through one more signal cycle at peak hours. So we're assuming a 2-minute delay due to that. The result with this now is ABC is a positive result now, that there is less impact to ABC when compared to conventional construction by a factor of 73%. So let's work our way through the rest of the matrix now that we've made a decision that this is the preferred way to build the bridge, which is detouring traffic down the ramps for I-395 and keeping Route 85 open with a signal. As Tim mentioned before, cost evaluation is a big part of the Connecticut DOT matrix. This project was estimated at $5 million. Some of you may be having a little agita about that $5 million cost. In the Northeast, we have very expensive bridges. That's another story for another day, but that's actually not a bad price for us. If you go to other parts of the country, like New York City, that number is ridiculously low. So it's just where we are. The estimated construction engineering and inspection costs, field office for the projects this size would be approximately $5,000 per month. The CE&I staff for a job this large would be $60,000, both in the field office and the main office. So the total monthly costs are $65,000 per month for managing a construction project. The net time savings by going to 2 one-week closures, the estimate is that we can save 15 months of total construction for the entire project. We're estimating a premium for ABC of 20% based on our previous experience. Our MPT savings, our MPT in Connecticut stands for Maintenance and Protection of Traffic, which is your traffic management work. We're estimating that if we go to conventional construction, that the installation of all the barriers, the shifting of the barriers for 3 different stages would result in a cost of approximately $150,000. So if we go to ABC, we can eliminate a significant number of the barriers. We still have some barriers, but not nearly as severe. So let's look at the cost analysis. So the premium for ABC, we're paying an extra $1 million for ABC on this project. That's based on that 20% of the $5 million cost. However, the construction engineering and inspection costs are $975,000 by knocking 15 months off the total project schedule. Significant number, and so I can't stress that enough. These are real dollars. These are dollars that are not included in the bid price. The bid price will come in $1 million higher, but at the end of the day, the DOT will spend $1 million less in construction, engineering, and inspection costs. Now, of course, some states don't spend this much on CE&I, but in Connecticut, this number works. These are the numbers that we typically see. Again, we mentioned we would save $150,000 in traffic management costs. So therefore, the tally of ABC is actually $125,000 less expensive than conventional construction, or 3% reduction. This is not unusual. We see this quite often, especially on multi-stage projects that go on for multi-years. So this is a great example showing where actually ABC is less expensive than conventional construction when you factor in total project costs. So let's go to the scoring. Tim mentioned this before. He went through the scoring equation, not scoring equation, the scoring parameters. The first one is average daily traffic. We have a case where our average daily traffic is above 40,000 and less than 70,000. And this is both the combined traffic above the bridge and below the bridge. So we fall into category 3. The user impact reduction, the spreadsheet automatically populates this box based on the calculations we just went through. And the answer is we're looking at a 70+% reduction in roadway user impacts. So that gets a 4. The bridge location, this is a relatively urban bridge near major traffic generators. We have the mall nearby and it's near a city. So we give that a 4. Moving on. Use of typical details. This is a fairly straightforward bridge. It has skew, but no curvature, parallel beams, simple framing. So we felt this fell into a category of 4 as just a skewed bridge. Oh, by the way, in these scores, it's okay to enter in a score of 4.5. That's definitely within the range of what you can enter in these things. If you think something is between a 3 and a 4, you can enter 3.5 if you want. You don't have to enter in a whole number. Work zone geometry, we gave this a 3 because it was an average duration project with average geometry and flow. We didn't have curvature on I-395, relatively good geometry on the ramps, so we gave it an average, we gave it a 3. Site conditions, again, we have a score of 0 to 5. You can enter in 2 and 4. You can logically go between the 2 numbers, but we think this is a minor construction limitations. As you recall, we don't have utilities on the bridge. We have that commuter parking lot under the bridge that we could use. So there's no waterways under the bridge. So it was a pretty minor construction limitations. The contractor would be given quite a bit of area to work under this bridge. So we gave it a 3. You could argue this might have been even a 4. As Tim mentioned, there are 3 factors in the scoring that if they're not applicable to the spreadsheet adjusts for that factor, the fact that they don't get counted in the total score. And this includes railroad impacts, environmental and water handling, and waterway limitations. Again, we don't have waterways and we don't have significant environmental effects because we have pavement under the bridge and there's no railroad. So these are all scored 0. So let's look at the cost analysis. As I said before, ABC was cheaper. It was less expensive than conventional construction. So the factor is -3%. Actually, I might have a typo here. Actually, we put a 4 in for the cost factor. Reality is it should be a 5. So I apologize. I entered a number in wrong, but we'll see. It comes out good. At the end of the day, things come out good anyway. But reality here is, yeah, it should be a 5 here. And here we go, total score. We go through the weighted factor scoring analysis, and run down all the numbers, and we get an ABC rating of 75, which, as Tim mentioned before, that's a go for ABC. This shows a good example of where initially we looked at a detour, it didn't look good. Then we took our reality hat, put that on, and looked at, well, what if we didn't close 85? How would that affect construction? And the answer was not that much. And we took advantage of the fact that Route 395 had a fairly low traffic volume and that we could actually essentially turn a grade separation interchange into an at-grade interchange with signals. This is essentially what we did. So let's take a picture, let's look at some pictures of construction. We got some nice shots here. This bridge was completed not too long ago, showing the erection of the deck panels. These are very similar to the deck panels that were shown in the first presentation, where we have a longitudinal post tensioning, blockouts for shear connectors, and leveling bolts. So here we are 30 years later, we're using the same details because they work. Nice shot here showing the panels being set. You can see the panels, if you look off in the distance, I-395, even though there's no cars in the picture, that's actually open to traffic. Again, the ADT was not ridiculous in 85 on Route 395, but here we are building the span that is closed at the time. Again, this traffic is detoured down the ramps that are nearby. Nice aerial shot from a drone showing the entire site. And there's a couple things I want to point out. One is this is showing this half of the bridge is finished, open to traffic. It has not yet been paved, but it was done in 7 days. And we're working on the second half of the bridge. But the key thing to look at, one of the questions that was posed, I think early on was, or hypothetical questions we came up with was, how did your predictions work out with reality? And this is reality. This is showing midday, this is during the day. This is the traffic coming down the diamond ramp and going up the other ramp. You'll notice there's not a big backup here. Matter of fact, there's virtually no backup here. That the prediction of the number of the ADT and the number of vehicles using this diamond ramp exit was reality. It was not. We did not see large backups here. This did work really well, and by keeping Route 85 open to at least 2 lanes, we kept traffic flowing at 85, and it all worked well. So the key thing of using ABC here was twofold. One, we got the job done quickly, but two, it was actually cheaper. So it's something that a good example of a project where you got to take all the parameters into account when you make an ABC decision, not just look at roadway impacts. We like to look at everything, including cost. That concludes my presentation. I believe I'm 2 minutes early, I think, so I'd be happy to answer questions. We have 10 or 12 minutes for questions.
Thank you, Mike. We'll now begin the Q&A session. Paul?
Okay, Mike, thank you. The question here was, the project have longitudinal post tensioning?
Yes.
And would you consider the use of UHPC?
The answer is now yes. When this project was being developed, it was a little in the early use of UHPC. There were only a handful of states experimenting with it. Today, we would definitely consider UHPC. I'm a big fan of UHPC. The reason why we would consider it for this job is because it was a 7-day closure. If it was a weekend closure, I would shy away from UHPC because the time it takes for UHPC to gain strength is usually a day and a half to 2 days. When you're doing weekend construction, we don't have a day and a half to 2 days. But with a 7-day closure, it is very reasonable to do that. So that would work well here. This would be a good candidate project for that as well.
Okay. And the question was, and you kind of covered this at the end. You showed the picture of the traffic. How did the actual project traffic management compare to the estimates? And the one y'all ended up picking, keeping the diamond interchange going, but it worked on all the other detours and everything else, everything you had, everything you figured.
Yeah, the key is we eliminated the detour for Route 85. That would have been problematic. But the diamond, like I said, the best way to describe it is we converted a grade separation interchange into an at grade interchange, where we essentially had a signal at the end of the ramp. And fortunately, the ADT was low enough on the interstate such that it didn't mess up with the traffic on Route 85, which was actually the control for the site.
I'd like to add that I'm sure there was a reduction here too, due to the advance notification and
Yep.
PR. State put out warning drivers in this area here of what was up for the next 2 weeks.
Okay. There's a question that came in beforehand, and but I was going to ask it now. It says, this is a deck replacement. It says, what is the most commonly used ABC method on the Connecticut DOT projects? You've shown a bunch of them now for deck replacements, and and how successful has this been? Looks pretty good, but go ahead.
Yeah. I'll speak to that one. My last presentation is going to cover the various ABC approaches that we've taken for, I think we have now 138 ABC projects. But modular deck beams is the most common approach that we've used. And I'll give reasons for that in the last presentation. So I'd say deck replacement on existing steel only happens if the steel is in good condition, and if it doesn't have significant corrosion issues. And typically bridges of this vintage do have corrosion issues. They're all simple span bridges, and they've had leaking expansion joints at pier and abutment locations. So we have a lot of section loss typically at beam ends. And there may be capacity issues too. So this bridge was probably unusual in that respect, that the steel was very serviceable for another 25 years.
Yeah, that's a good point, Tim. And I'd like to bring up the fact I brought this picture back up, and we're not talking much about this today, but we have in the past talked about link slabs. This is an example where precast deck panels are used with link slabs. So at the pier location, which is right here, you see blockouts in the panels, but there are no shear connectors in those blockouts over the link slab region. So this bridge actually has link slabs to eliminate the deck joint at the pier. So it's a little trick we're doing these days in ABC. As far as replacing, as Tim mentioned, modular deck beams with 2 steel beams and a precast deck are very popular. As you can see, looking at these details, the connection of a precast deck to a beam to get composite action is a significant connection. And what we're finding is that it's actually easier to, and the other thing we look at too, the cost of painting steel beams is quite a bit. It's quite high, and sometimes it's actually less expensive to replace the steel than it is to paint it. This case, it wasn't the case on this bridge because as Tim mentioned, the steel wasn't in that bad of shape. But so a lot of times, we're finding that with modular deck beams, it's actually less expensive, and it's actually a lot faster to build because you're not making that deck connection to the beams. The unit comes from the fabrication shop already composite, and all you're doing is connecting a deck level connection, which is quite simple. So we're seeing that type of construction becoming much more popular in the Northeast.
Okay. Can you go to your picture where you remove the deck?
Mm-hmm. Maybe that one?
The existing beams. Yeah, this was a non-composite bridge.
I believe it was composite. You can see the residue from the probably had spiral shear connectors on it before the deck was removed.
Okay.
Yep.
Okay. So then you had a composite bridge and you went back with the composite. Okay, that's fine. Okay, that's the questions that we had that came in beforehand. I'm going to ask Jugash if we've got some questions during the question and answer session. Jugash?
Yeah, thank you, Paul. There were a couple of questions that came in. The first one is asking what was done at the skewed end. Have you had to contend with considering lead-based paint abatement on top flange of the girders? I wonder if that's the next question. But just address the skewed end of it.
Yeah, the answer was there were closure pours done at the end of the bridge. The design team, I think, investigated the use of trapezoidal shaped panels. The thought was with a 7-day closure that it was some cast in place construction was reasonable as long as most of the deck was precast. So you see in the photo here, you can see these trapezoidal pieces at the end were done with cast in place. That's one of the issues with longitudinal post tensioning. The detailing of these end panels, if they're skewed, it gets very complicated. So if we were to use, this is why I mentioned before about UHPC might be something we would consider today. You can go with trapezoidal shaped panels because you don't have those anchorage assemblies for the longitudinal PT. So there were closure pours. We with 7 days, there was ample time to do those and to get that concrete cured. So there was that was the choice done for this bridge. But have this bridge been done today, we might see some different detailing.
Okay, thank you. So did you have to contend with lead-based paint abatement on the top flanges of the girders in your?
I'm not sure about the top flanges, Tim. I know the steel itself had lead paint, so the repainting we had to deal with abatement. But we do a lot of painting, so we're actually our contractors are very familiar with that. But as far as the top flange goes, I think there might not have been paint on the top flange.
Yeah, usually the top flanges are bare, but any project that has lead paint in it has specifications that address the concerns the contractor needs to follow with that. And this did include full painting, so this would have been abrasive blast cleaning and removal of all lead paint. So I'm sure this was was adequately covered in the project.
Okay. The last question. Girders in your analysis of the time needed for conventional deck replacement construction versus doing offsite remediation at the ABC. Not sure the question is very clear.
Yeah, I was going to ask you that. I'm not quite sure I understand that. Well, maybe it was referring to, do we consider maybe like SPMTs or no? It doesn't really make any sense. But like I said, we look at all forms of ABC when we scope out these projects, and the key thing is, and that is changing over time as we get more sophisticated with ABC. Like I said, this project today might very well be a UHPC joint project, but all options of ABC are considered for each site. We do our structure type studies, and we look at whether or not we want to use SPMTs, whether or not we want to use modular deck beams, precast decks. There's quite a bit of work that goes into that portion of the decision process, which essentially comes into like a life, as Tim mentioned before, a life cycle cost analysis onto whether or not we want to paint the steel or replace it, say, with something like weathering steel. That's something we consider in every project.
Yeah.
We also look at concrete as well. I'm not going to throw, it's not all steel. We do concrete beams. We do precast concrete next beams and things like that as well.
I'd like to note here that Mike's familiarity with this bridge project and the next one stems from the involvement of their firm, CHA, with their preliminary bridge rehab study report that looks at these various alternatives, the ABC and conventional. So, you know, Mike's firm is one of with 2 other firms that serve in that function of that consultant liaison engineering that helps the department evaluate the best approach to these kind of projects.
Mm-hmm. And also, like to mention, as Tim mentioned, our firm, we have this, our contract is called Consultant Liaison Engineering, which essentially we assist the department in management of their program. We have a number of bridges assigned to us, and there is another consultant involved who actually did the design of this and I apologize to that consultant. I can't remember who it was, but there was another firm that did the final design of the bridge, and maybe during one of the breaks I'll look that up and I'll give credit where credit is due.
Okay. Thank you, Mike and Tim. That's all the additional questions that came in.
Great. Thank you.
Okay. Thank you, Paul and Jugesh. We're now at the end of the 40-minute module. Thanks again to Mike for presenting the 4th module and to Mike and Tim for responding to the questions that have come in. We appreciate all your questions.